Ever feel like AI is stuck in overdrive? Like every time you look away, there's some new breakthrough
You
and
can feel like trying to learn a new language overnight.
yes, exactly. And today's deep dive is no exception. We're talking LLMs again, but with a twist.
Right, we're getting into some seriously cutting-edge stuff.
Buckle up, everyone, because we're about to explore how to make LLMs even more powerful, and the method, well, let's just say it's surprisingly elegant.
It's all about synthetic data. Specifically, a paper called Towards a Theoretical Understanding of Synthetic Data in LLM Post-Training, a Reverse-Bottleneck Perspective.
Catchy title, right? But honestly, when I first saw Reverse-Bottleneck, I was hooked. It sounds kind of like, I don't know, almost like a magic trick or something.
It does have a certain ring to it. And the best part is, the core idea is surprisingly intuitive. We're basically talking about creating data artificially to enhance how we train these LLMs.
So instead of hunting down even more real-world data, which we all know can be a pain, we're making our own.
Precisely. Think of it like this. You know how in machine learning, sometimes we simplify complex data to help a model learn. That simplification, that's like squeezing information through a bottleneck. Some detail might get lost along the way.
Okay, I'm following. So where does the reverse part come in? Are we unsqueezing the bottleneck?
In a way, yes. We're using the trained LLM itself as a starting point. It's already full of compressed information, right?
Because it's learned from all the data we've already fed it, right?
Exactly. So we use the LLM to generate new data that expands on what it already knows. It's like we're, I don't know, reverse engineering the data creation process.
Whoa. Okay, so it's generating its own study material based on what it's already learned. That's pretty meta when you think about it.
It really is. And this is where the paper gets really interesting because it's not just about generating any old data. It has to meet certain criteria, specifically faithfulness and diversity.
Okay, so like faithfulness makes me think it has to be accurate to the real world, right?
You got it. If the synthetic data is supposed to be about, say, financial news articles, it needs to sound like the real deal. The tone, the style, the jargon, all of it.
Otherwise, it'd be like learning a new language from a textbook that's full of made-up grammar rules.
Yeah.
Useless.
Exactly. And that's where diversity comes in. We don't want our LLM to get stuck in an echo chamber. The synthetic data needs to be varied enough to represent the real world.
So sticking with the financial news example, we'd want articles about different companies, different market trends, global economics, all of that.
Exactly. A rich tapestry of data, all generated by the LLM itself. And the paper delves into how to control that generation process to get the best results, which is where things get really interesting.
So we're sparking the LLM's creativity, giving it a starting point, and then how do we actually guide it to create this high-quality, diverse, and accurate synthetic data? So it's like we're giving the LLM a set of creative constraints, right? Like, hey, be creative, but stay within these lines. But how do we actually know if this whole synthetic data thing is working? How do we measure if it's making the LLM smarter?
That's where the paper gets really into the weeds, but in a good way. They actually quantified it. They use this term, generalization gain via mutual information. GGMI for short.
GGMI, got it. Catchy. But what does that actually mean in plain English?
Essentially, a higher GGMI score means the LLM that was trained on synthetic data is outperforming the one that was only trained on real data. Like, it can take what it's learned and apply it to new situations better.
Which is ultimately the goal, right? We don't just want LLMs that can memorize. We want them to actually understand and reason. So a higher GGMI score equals a smarter, more adaptable LLM.
Got it. Did they find that using synthetic data actually increased the GGMI? Like, did it work? They did. And they identified several factors that influence how much of a boost you get. One of the biggest. The information content of the generative LLM itself. Basically, the smarter the LLM that's creating this synthetic data, the better that synthetic data will be.
Oh. So it's like the more knowledgeable the teacher, the better the student learns.
Precisely.
Yeah.
Garbage in, garbage out, right?
Yeah.
But it's not just about the teacher. It's also about the curriculum. They talk about minimizing conditional entropy, which in a nutshell means reducing uncertainty between the synthetic data and whatever task you want the second LLM to learn.
So the synthetic data needs to be laser focused, no distractions. Interesting. What else did they find?
Another key ingredient is entropy decrease. This basically means that when we generate synthetic data from real data, we're actually removing some of the randomness, the noise that exists in the real world.
So we're like purifying the data, making it even more potent.
Exactly. And of course, we can't forget about diversity, which we talked about earlier. Striking that balance between being faithful to the real world and having enough variation is super important.
It's like We're trying to give these LLMs the richest, most comprehensive education possible, whether it's from real data, synthetic data, or a blend of both, which, by the way, a lot of the big players are already doing. The paper mentions that Llama, Falcon, Quen, even GPT-4 have all used synthetic data. That's kind of mind-blowing, right?
It really goes to show that this isn't just some theoretical idea, it's already shaping the future of AI.
hmm
And honestly, I think we're just scratching the surface here.
It's like we've discovered a cheat code for AI training, and the possibilities are endless. And there's always a but, right? Were there any limitations to this research? Like, did it all just work perfectly in practice?
Well, one thing they emphasize is that their simulations, while useful, are still a simplification. They use something called Gaussian mixture models, or GMMs for short.
EMMs, got it.
Hmm.
Don't think I could handle a crash course in those today.
No worries. The main point is they're a way to represent complex data, but they can't capture every single nuance of the real world.
Right, because reality is messy, right? No matter how sophisticated our models get.
Exactly. So more research is definitely needed to see how these principles play out in the real world with those massive LLMs. But as a starting point, this paper is incredibly insightful.
Totally agree. It's given us a glimpse into a future where data limitations might not be so limiting after all. Speaking of the future, I think it's time we shifted gears a bit and talked about what all of this means for, well, everyone else. Because this isn't just some abstract concept, it has real world implications. So we've covered a lot of ground here, really dug into the how and the why of this whole synthetic data thing, this reverse bottleneck idea. But I think the big question on everyone's mind is, why should they care? What's the takeaway for the average person?
For me, it's the potential that's both exciting and honestly a little bit mind-blowing.
Mm.
We might be looking at a future where being limited by real-world data, well, those limitations might not be so strict anymore.
Just like we can just make more data on
Yeah.
demand.
In a way, yes. And not just more data, but better data. Imagine training chatbots that are more nuanced, more helpful, because they've learned from a wider range of experiences, all thanks to synthetic data.
So it's not just about having enough data, but having the right data. It's about tailoring the data to the specific task or challenge, which is fascinating.
Right. And this isn't some far-off thing either. We talked about how LLMs like GPT-4 are already using synthetic data. If the big players are using it, you know it's got to be powerful stuff.
It's like this whole field of AI is leveling up right before our eyes. What other fields could this impact?
Oh, wow. I mean, think about anything that relies on data. Right? Finance, for sure. Marketing, definitely. Scientific research, absolutely. Synthetic data could change how we approach all sorts of problems.
Right. It's like we're giving researchers, innovators, everyone a new toolkit. A toolkit filled with data that can help them do things that weren't even possible before.
It really is a potential game changer. And for me, that's what makes this research so exciting. It's not just about making LLMs a bit better. It's about reimagining what's possible with data itself.
That's a great point. It's like we're not just improving the tools, we're changing the very building blocks of how we understand and interact with information.
Exactly. It's a fundamental shift.
Well said. It's been a fascinating deep dive, and I, for one, am both excited and a little terrified by the possibilities. Thanks for joining me today.
Anytime. This kind of stuff always gets me going. Lots to think about.
Isn't that the truth? Until next time, everyone, keep asking those big questions and stay curious.